All right, welcome back. We are now in section 5. All right, and just as we did for the future value when we did annuities, we can take the ordinary annuity tables, all right, but with some modifications we can make it an annuity due table. Okay, so again, the steps that we need to take are to calculate the number of periods, compounding periods of the annuity, so that's the number of years of the annuity times compounding periods per year. But this time, since we're doing present value, instead of adding one period, we're going to subtract one period. Because since we're making a payment at the beginning of the term, okay, we are now needing a little more money because we're taking that payment out ahead of time. All right, that is not getting interest. Okay. That actually is getting interest. I apologize. So the factor will be a little less because we're going to earn interest again. Remember, the interest shifts up. We're going to earn interest on that first payment. So when we're doing present value off of these tables, once we find the number of periods, we're going to subtract one because we're now earning interest on that first period. Whereas when we make on the ordinary annuity, when we make the payment at the end, we're not earning any interest at that point, okay? All right. So then we calculate the interest rate period. So that's the total number, all right? Or the interest rate per period, that's the nominal rate divided by periods per year. That's our I. So find the table. We find the factor, all right? And now we're going to add 1%. So we're going to subtract from the small n to find our n, total number of periods, and we're going to add 1 to the factor, all right, to give us the appropriate factor for the annuity due. All right, so when we did future value, we added 1 to n and subtracted 1 from the factor. When we do present value, we're going to subtract from the n and add 1 to the factor. All right, so it's just we just flip where we subtract and where we add. All right, but very simple to do. So as we walk through this, how much must be deposited now at 10% compounded semi-annually to yield an annuity payment of $2,000 at the beginning of each 6-month period for 7 years? So it's the beginning of the period, it's an annuity due. All right, so the number of periods, since it's the number of periods we're looking at, 7 years at 6 months. So 7 years semi-annually. It's going to be 7 times 2, which is 14, but now we subtract 1. So n is going to be 13. All right? And we know that it's 10% is the nominal rate, and we're compounding it semi-annually. So we got to take 10% divided by 2, so that's 5% each period. So my small I is going to be 5%. All right? And then from the table, the ordinary annuity table factor for 5% at 13 periods. All right? We talked about the 13 periods. We subtracted 1 because it's an annuity future value of, or I'm sorry, present value of an annuity due. All right, so we subtracted 1. So at 13 periods, at 5%, which is the small I, interest rate per period, we find that it is 9.39357. All right, are they right? All right, 5%, 13 periods. 5%, 13 periods, 9.39357. All right, I think they're right. So now we take the factor that we found and we have to add 1 to it. So it should be 10.39357. Now we take the payment, all right, of $2,000 times the new factor for the annuity due, and that will be a present value of $20,787.14. All right, which means that they were putting away, let's see, $2,000 twice a year is $4,000 times 7, so it's $28,000. So just short of $8,000 they'll earn in interest. All right, they want a future value of $28,000. So 28 minus 20 should be just short of $8,000. Okay, so that's how much interest they made. Let's go ahead and let's try exercise 5. We will practice. It says, you are an accountant at a lumber company. Based on sales and expense forecasts, you have estimated that $10,000 must be sent to the IRS, taxes, for income tax payments at the beginning of every 3 months. Every 3 months is quarterly. For the next 3 years. How much must be deposited now at 6% compounded quarterly to yield the annuity payment needed to yield $10,000 every 3 months? All right, so 3 years, nominal rate of 6%, compounded quarterly. Go ahead and figure that out. Find the table factor, and I will come back with the answer.